First, in the File section in the upper left corner, create a new project. Then, we can see a number of options in the MLS Process section. The first and second are data import options. There are two methods of importing data, import from device and import from hard disk. We chose to import the data from the hard disk. Before that, we need to import the data from LiDAR's data card to the computer in advance. As you can see, the software automatically recognizes the data in the folder. But here, we need to manually enter the coordinates of the RTAKA we set up. After all parameters have been entered, click on Save and Calculate to start the calculation. Calculation completed. If the calculation fails, click Quality Inspection Report and Data Quality Inspection to check the cause. Following this, we click on Photo Arrangement. Here we can see that the number of POS in the POS list is 204, while the number of photos is 211. This is because the LiDAR will take 7 pictures when it is activated on the ground, so we can delete the extra 7 pictures in this interface. Click OK to continue. Here you can choose whether or not to check POS with photo or not, later so that we can generate DOM. Confirm and continue. Now, let's click on the Strip Division option to divide the flight path. As you can see, there are 2 division options here. After determining the coordinate system, we select the first automatic partition option for automatic division of the flight path. In general, the automatic partition can divide most of the flight path trajectories. Soon the division will be completed. Click on the Exit option to exit the Strip Division interface. Next, we click on the Point Cloud Fusion option to fuse the point cloud data collected by our LiDAR. Check the settings. Usually we choose a 70 FOV for the fusion. Confirm and start the fusion. It usually takes a few minutes. Fusion completed. Import the fusion results. Here's the raw point cloud data we've fused. In the leftmost column, we can choose different ways to display the point cloud. In the Tools section, click on the Section option to view the point cloud profile. Check the right half of the screen and select the Flipped Line option in the leftmost column to display the point cloud data as flight paths. Let's take a look at the point cloud data on the ground. After checking this, we can click on the Control Point Report option to import the control points that have been marked earlier. In this order, confirm. Calculate. This value is the normal level for raw data. For the next step, we click on the Point Cloud Refinement option for further processing of the raw point cloud data. Choose whether or not to mark these 3 options depending on your processing requirements. In this field, import the POS file, which is the largest one in the POS folder of the corresponding sortie. Start the point cloud refinement. Likewise, this will take some time. When we're done, import the refined point cloud results. These are the refined point clouds, and at the same time we remove the original point cloud data. Let's have a look at how the refined point cloud looks like. Obviously, the point cloud data is thinner after refinement. The display of the spire houses has also been significantly improved by removing the excess noise parts and correcting some of the trajectory errors to mitigate the degree of delamination. Click on the measurement tool to measure the difference from the checkpoint. It's about 4 centimeters. It's within the normal range. Now let's click on Control Point Check again and make a calculation. These are the results of the refined point cloud.